going to start off by reviewing scientific notation with you. So if we want to put a number into scientific notation, that's the first part of this video, we're going to go over how to do that. So how do you get a number that is not currently in scientific notation? We'd call it being in standard notation. How do you get it to scientific notation? So what you do is you have to take your original number and you have to turn it into a number that is greater than or equal to 1 but less than 10. So you want this number that you create to be greater than or equal to 1 but less than 10. Notice it cannot equal 10. Once you do that, you're going to multiply by 10 to a power. If your original number, so the number that you started off with, is less than 1, then you're going to have 10 to a negative exponent. But if the original number is greater than 1, then you're going to have a positive exponent on that 10. Now, I put a little bullet here. Important note, whether if it's in scientific notation or in non-scientific notation, standard notation, the number should always keep the same number of significant figures. So no matter what way you write the number, whether it's in scientific or standard notation, you always have equal significant figures. So we want to check that at the end. So let's do a couple examples. If we start with 34,870, well, that automatically breaks this rule. 34,870 doesn't fit here. Yeah, it's greater than 1, but it's not less than 10. So we're going to turn this into a decimal. So we're going to put 3.487. Now the question is, do I need this 0 here? Well, is the 0 significant in the original number, in 34,870? And the answer is no, that 0 is not significant. Here we have 4 significant figures. So that means that in this number, I also want to have 4 significant figures, which I have 3, 4, 8, and 7 are 4, add up to 4, so there's 4 significant figures. So I do not include the 0. Then I'm going to multiply by 10. It says if the original number is less than 1, well, that's not true. So we don't have to worry about the first bullet, but if the original number is greater than 1, then we're going to have a positive exponent. So I know this exponent is going to be positive. So you could do a little scratch work over here. If I have 3.487 and I want to turn it back into 34,780, I'm going to move the decimal to the right. But how many times? So 1, 2, 3. That would give me 3,487, but I want 34,870. So I've moved it 1, 2, 3 times. I need to move it one more. So I'm going to move it one more to the right. So I add a 0, which would now give me 34,870. So I moved it 1, 2, 3, 4 times. So that's positive because I need to get 3.487, a small number, back to 34,870, a large number. I have an exponent that is positive. Okay, let's try another one. So this time I have 0.0023. So how many significant figures are in 0.0023? The question really is, are these zeros significant? The answer is no, they're not. Those are just placeholders. They are not at the end of the number and to the right of the decimal. Yes, they're to the right of a decimal, but they're not the end of the number. They're not after the 3. So they're not significant. So here we have 2 significant figures. So when we cross into scientific notation, we want to keep 2 significant figures. So this would be 2.3 because it's got to be bigger than 1, less than 10, times 10. Now notice I have to take this 2.3 and make it to a smaller value than 2.3. I have to make it to 0.023, so I know I'm going to have a negative exponent. And remember, the exponent tells you which direction you're going to move the decimal and how many times. So negative, I'm going to have to move it back to the left. So if I have 2.3, how many times do I have to move it to get to 0.0023? So if I move it 1, that would give me 0.23. So I got to keep going. 2, I can add a 0. 3, I can add one more 0. So I'm going to move it 1, 2, 3, and that's to the negative third power. Again, it's a negative third power because I'm trying to get to a smaller number than 2.3, and I'm moving the decimal to the left. Okay, last one is very similar to what we just did. The tricky part here is with the significant figures. So we're going to look at this number, 0.0300. So this 0 is not significant. It's important, but not significant, just like here. It's a placeholder, like the one above. Now, are these zeros significant? The answer is yes. They are significant because they're after a decimal to the right of, or they're to the right of a decimal at the end of a number. Okay, so that means that all of these are significant. So we have three significant figures in this. That zero, not significant, just gives the number value. So we have to include those two zeros when we're putting it in scientific notation. So 3.00, because this also has three significant figures. Notice it always matches. Two significant figures, 4, 4. All right, times 10. We know it's going to be a negative exponent, and we're going to have to move it. If I have 3.00, I move it one time, two times. Okay, so negative second power. So key things, always make sure this number here, the beginning number, is greater than or equal to 1, but less than 10. And then it's always times 10 to an exponent. If the original number here is less than 1, you're going to have a negative exponent. If the original number, like the first one, is greater than 1, you have a positive exponent. All right, now let's go backwards. What if we convert from um, scientific notation to standard notation? So our rules are kind of just reversed. So it says simply just move the decimal point. If the exponent on 10 is negative, you move it to the left. If the exponent is positive, you move it to the right. And again, I have the same note as above. You always maintain the correct amount of significant figures that you started off with. When it's in scientific notation and counting significant figures, remember we just look at the beginning number before times 10. So 2.40 has three significant figures, so we're going to make sure we have three. Notice we're moving it to the left because it's a negative to the negative fifth power. So there's a negative sign right there. So I have 2.40. I'm going to move it left 5 times. So 1, 2, 3, 4, 5. So here's my new decimal point. Fill in all those zeros. 1, 2, 3, 4 zeros. And make sure you keep that 0 because it was significant. So we have 0.0, 1, 2, 3, 4 zeros, 2, 4, and add that extra 0. So we still have three significant figures. The next one is almost the same. The only thing is it says 2.40 times 10 to the negative fifth versus 2.4 times 10 to the negative fifth. This only has two significant figures. So we just have to take the above number and do one change. Cut off that last 0 because we don't want it there since up here that counts as significant and we only want 2 here, so I don't put it on. Number 3, this time we have a positive exponent here. So we have a positive exponent, so we're going to move it 4 times to the right. So 6.89, 4 times, 1, 2, 3, 4. Add your zeros in. 6, 8, 9, 0, 0. So there's your answer. These zeros are not significant because there's 3 significant figures here. So you keep it 3 significant figures here. So this is 3 significant figures. This has 3 significant figures. All right, then the last part of this video, we're going to go over how to use your calculator with scientific notation. So I have 3 calculators up here. You're going to have probably one of these calculators. So you can use one of these or whatever one you use, follow along with it. So for the first one, most of you probably have the graphing calculator. You're going to want to use the second, and then right above the 7 is a comma. And it's hard to see it on this, but this right here, these letters say E, E. So you're going to be looking for that if you're using your graphing calculator. If you have one of these scientific calculators that I have in my classroom, it's very similar. You're still going to use your second button. So the second is on the top left. And then your your EE is still right above the 7. So it's still right here. So there's your EE button. And then if you have a calculator like this, I know some classrooms have these calculators, you just have the EE button right here. You don't need to hit a second. Okay, so let's try to enter some of these into our calculator correctly. So I've given you directions right up here how to do it. So notice it's the EE button. On the calculator, that EE button, and I just showed you where those were at, that EE, when you hit it, it means times 10. So you already have the times 10. So that means you do not need to enter the times 10. So don't do that. That's where students make mistakes and it gives you the wrong answer. So as soon as we get the EE button, your calculator recognizes that scientific notation. It already has the times 10 and we only have to enter in the exponent. So once you see the E on your calculator, on the calculator, it doesn't show up as EE, it just shows up as E. It'll flash on the screen and I'll show you that in a second. So you just then add the exponent on. You don't have to use any parentheses, and then be sure to round your final answer to the correct amount of significant figures. And the last thing, this is really important. We've got to get used to looking at our calculator answer. Sometimes we just look at the beginning of the number, but you need to make sure you look all the way to the end. So look at it shouldn't say the enter answer, the entire answer. Okay, so it should say the entire answer on your calculator because there might be an E on it. And then that E, you're going to not write it down. You're going to translate to times 10 into the exponent. So let's try a couple of these. So first thing we're going to do is in our calculator, we're going to type in 3.2 and then you're going to find that E button. Okay, so that EE button, find that on your calculator. So if you're using a graphing calculator, you're going to hit second, comma, or if you're using like this pink calculator, second, X button above the 7. Or if you're over here, you're just going to hit the EE button. So you're going to have, enter in right now, do it along with me. So we're going to have in 3.2 and then our EE. So right now my calculator looks like this. So that was the button I hit, but my calculator says 3.2. Now it says E. Remember that E that's showing on my calculator means times 10. So this times 10 is already done. I just have to put the exponent of 5 in. So we're going to enter 5. So now my calculator says 3.2 E5. Then I'm going to hit my divide sign. So I've got slash on my calculator. I'm going to enter in 4.00. So then I have 4.00. Find your EE button. So do that again, second, wherever it's at on your calculator. And then I'm going to hit my exponent of 15. So the second E15. And my calculator tells me this. My calculator, when I look at it, right now it says 10 E negative 11. We are not going to write that as an answer. That's wrong. We need to put this in some sort of mathematical notation. So this is what my calculator says. You need to translate this correctly. So what that means, this is the correct answer. 8 times 10 to the negative 11th power. So see how the E was a times 10. Now I have to go back and look. Do I have the right amount of significant figures here? So if I look at this, I don't care about the times 10. 3.2, there's 2 significant figures. 4.00, that's 3 significant figures. My rule for division and multiplication says the least amount, so I get 2 significant figures. Right now, 8 times 10 to the negative 11th only has 1, so my final answer would be 8.0 times 10 to the negative 11th. There's my answer. All right, let's do another one. So you have 6.022, second. In my case, I'm using a graphing calculator, so I'm going to hit comma 23. So now my calculator says 6.022 E23 times, and I'm going to enter the next number, 5.02000 E, so a second, comma again for me for my graphing calculator, 4. Enter. Notice I didn't put any parentheses in. So my calculator is giving me this number. If I look at my screen for number 2, it says 3.023044, and then at the end of the number, it says E28. Okay, so that's what my calculator is saying. I need to take it and put it in correct scientific notation with the right amount of significant figures. So here, that 0 is trapped, so that gives me 4 significant figures. Here, are these zeros significant? Well, the answer is yeah. They're at the end of the number after a decimal. So those 3 are significant, and that 0 is significant because it's trapped between a 5 and a 2. So we have 1, 2, 3, 4, 5, 6 significant figures. So my answer, I have 4 significant figures. So let's go through. 3, 0, 2, 3. That's where I'm going to cut my number off. This 0 says, oh, keep the 3 the same because I don't want to round up. 5 or higher rounds up. So I have 3.023 times 10e28. So remember the e is times 10, 28th power. So you try the last one and see if you can do it correctly with the correct amount of significant figures. So you might want to pause the video right now, try it, and make sure that you get it correct. Okay? All right. If you did it correctly, you should end up with two significant figures because 3.7 has two. And here's what my calculator gave me once I've rounded it. So 1.2 times 10 to the 18th power. Again, you don't need to use any parentheses if you use that EE button on your calculator. So you have to practice these, and if you do, you will be fine. Make sure you ask questions if something isn't clear.